Well, this is the first movie of our chapter of electricity. Let's look what are the uses of electricity. As an introduction, well, we got radio, for example, or we got a computer, we all use that, and we got a TV. All typical uses in the house, and there are a lot of more of those, but that's enough for the introduction. We got also that electricity is a natural phenomenon. We have all seen lightning, and electricity is also part of our body, in the nerve cells, and it can save our life. For example, when we have a cardiac arrest. So, electricity is important in our daily life. Let's look what it is. And we start with a little experiment. You see me here rubbing a PVC rod with a woolen cloth. And what happens? Let's do that again. Rubbing the PVC, and I come close to paper, and a little piece of paper, they are attracted to the rod. How can that be? Well, there is a kind of creation of charges. What happens? I got the PVC rod here, PVC tube, and I use a woolen cloth to rub it. Rubbing it with a woolen cloth. And you see small charges, visible to the naked eye, they jump over to the PVC tube. So in fact, it's not the creation of charges. I used the wrong word here. It's transfer of charges. They transferred from one object to another. Let's do another experiment. You see me here rubbing an ebonite rod and put it so it can rotate. I use another ebonite charge, and when I bring it close to the smaller one, or to the one I can rotate, you see they repel one another. Then I use a glass rod, rub with the same woolen cloth, and they attract one another. So, we got several charges. Rubbing two ebonite rods together, repel one another. Rubbing one glass rod and one ebonite rod, they attract one another. There have to be two different kinds of charges. We got negative and positive. The negative ones, they repel one another. The positive ones repel one another. Minus and positive attract one another. So, like charges repel one another. Unlike charges attract one another. We got charges also in chemistry and biology. Like the chemical bonds are based on electric forces. And the same with the nerve cells in our body. It's the transfer of electrical charge in the nerve cell. Well, we need of a quantity and a unit. So the quantity we use is charge. The symbol will be Q, capital Q. The unit we will be using is coulomb, and the symbol will be a capital C. But 1 coulomb is a very large charge. We will be using in most of the exercises millicoulombs, microcoulombs and nanocoulombs, where milli is 10 to the minus 3rd coulomb, micro is 10 to the minus 6th coulomb, and nano is 10 to the minus 9th coulomb. Look at our atomic structure. Well, we got the nucleus, which is made up of positively charged protons and neutrally charged neutrons. And we got electrons orbiting the nucleus. It's a close enough approximation for our text now. The charge of one proton, plus, is the elementary charge. We find them no smaller. The symbol is E for elementary charge, not for electron, is 1.60 times 10 to the minus 19 coulomb. The charge of an electron, that's minus the elementary charge. So all electrons have the same charge, all protons have the same charge. This is the charge of all protons, this is the charge of all different electrons. Minus elementary charge is minus 1.60 times 10 to the minus 19 coulomb. Not to be confused with the symbol of electron. Number of electrons in 1 coulomb, let's find out how many there are. Well, the number is 1 coulomb divided by the charge of 1 electron. I dropped the minus here because it's just the number we need. And it's, well, 6.25 times 10 to the 18th, which is quite a lot. Well, we got to finish off the triboelectric series. Triboelectric series, which lists a number of materials, I've just given here a few examples. And on the top we find the most positive, and on the bottom the most negative, which means that by contact or rubbing, materials higher on the list will give electrons to materials lower on the list. Oh, I jumped here too quickly. So that means, for example, the glass, when rubbed with wool, gives its electrons to the wool, making the glass effectively positive. The wool, on the other side, is giving its electrons to PVC and ebonite. So it means that the wool gives its electrons, becomes positive, and the PVC or ebonite become negatively charged. So let's go to our next movie and see about the movement of those charges.